Docker. What is Docker? Docker is an open-source platform that allows developers to automate the deployment, scaling, and management of applications inside lightweight, portable containers. These containers package all the necessary software, libraries, dependencies, and configurations required to run the application, providing a consistent environment across different systems. Key features of Docker include containerization. Docker uses containerization technology to create isolated environments, known as containers. Each container contains the application code and its dependencies, making it self-sufficient and independent of the underlying host system. Docker Engine. The Docker Engine is the core component responsible for running and managing containers. It consists of a server-side daemon, Docker, and a command line interface, CLI, tool, Docker. The daemon handles the container operations, while the CLI allows users to interact with Docker through commands. Docker images. Docker images are the building blocks of containers. An image is a lightweight, standalone, and executable software package that includes the application code, runtime, libraries, dependencies, and settings required to run the application. Docker Hub. Docker Hub is a cloud-based registry provided by Docker, where users can find and share Docker images. It offers a vast collection of pre-built images, including popular software, frameworks, and tools, which can be pulled and used directly. Dockerfile. Dockerfile is a text file that defines the configuration of a Docker image. It contains a set of instructions to build the image, specifying the base image, adding files, setting environment variables, and executing commands during the image creation process. Docker Compose. Docker Compose is a tool used for defining and running multi-container applications. It allows you to describe a complex application setup using a simple YAML file, enabling the creation of interconnected services. Scalability and orchestration. Docker Swarm, a native clustering and orchestration tool for Docker, allows users to create and manage clusters of Docker nodes. It simplifies the process of scaling and load balancing containers across a cluster of hosts. Benefits of Docker. Consistency. Docker ensures that applications run consistently across different environments, eliminating the "it works on my machine" issue. Portability. Docker containers can be easily moved and deployed across various platforms, cloud environments, and operating systems. Resource efficiency. Containers share the host OS kernel, making them lightweight and efficient compared to traditional virtual machines. Isolation and security. Containers provide process-level isolation, enhancing security and reducing the risk of conflicts between applications. Rapid deployment. Docker containers start quickly, leading to faster development cycles and deployment times. Version control and rollback. Docker images are versioned, allowing easy rollbacks to previous application versions. DevOps enablement. Docker is a fundamental technology in DevOps practices, enabling collaboration between developers and operations teams. Containerization and its benefits. Containerization is a technology that allows you to package an application and all its dependencies, libraries, and configurations into a single unit called a container. This container can then be easily and consistently deployed across different environments, such as development, testing, staging, and production, without any compatibility issues. The key components of containerization are Container image, a lightweight, standalone, and executable software package that includes the application code, runtime, system tools, libraries, and settings. Container engine, the runtime environment responsible for running containers. Docker is the most popular container engine, but there are others like Containerd, RKT, and Creo. Benefits of containerization. Consistency and portability. Containers provide a consistent environment for applications to run, regardless of the host system. This eliminates the classic, "it works on my machine," problem and ensures that the application behaves the same way in development, testing, and production environments. Isolation. Containers provide process-level isolation, allowing multiple applications to run independently on the same host without interfering with each other. This isolation enhances security and reduces the risk of conflicts between applications. Resource efficiency. Containers share the host operating system's kernel, making them more resource efficient compared to traditional virtual machines, VMs. Containers start quickly and consume fewer system resources, making them ideal for scaling and optimizing resource utilization. Rapid deployment. Containers can be started, stopped, and deployed in a matter of seconds. This fast deployment allows for rapid development iterations and seamless scaling of applications to meet varying workloads. Scalability. Containers make it easy to scale applications horizontally by running multiple instances of containers across a cluster of servers. This elasticity ensures that the application can handle increased demand without manual intervention. Versioning and rollback. Docker images are versioned, enabling easy rollback to previous versions of applications if a newer version has issues or bugs. DevOps enablement. Containerization is a fundamental technology in DevOps practices, enabling developers and operations teams to work seamlessly together. Developers can package their applications into containers, and operations teams can deploy and manage them consistently across different environments. Application isolation and security. Containers provide a level of isolation, reducing the impact of potential security breaches. If one container is compromised, it doesn't affect the others or the host system. Simplified dependency management. Containers package all application dependencies within the container, reducing conflicts between dependencies and making application deployment easier. Cloud and hybrid cloud adoption. Containers are highly suitable for cloud and hybrid cloud environments, allowing applications to be easily migrated and run on different cloud platforms. Docker's role in simplifying application deployment. Docker plays a crucial role in simplifying application deployment by addressing several challenges and providing a standardized, consistent, and portable environment for running applications. Here's how Docker achieves this. Eliminating environment variability. One of the most significant challenges in application deployment is the variability of the underlying environments. Different operating systems, libraries, and configurations can lead to "it works on my machine" issues. Docker encapsulates the application and its dependencies within a container, ensuring that the same environment is maintained across all stages of the deployment pipeline. Packaging applications and dependencies. Docker allows developers to package their applications along with all the required dependencies, libraries, and configurations into a single container image. This image includes everything needed to run the application, making it self-sufficient and independent of the host system. Consistent deployment across environments. With Docker, applications behave the same way in development, testing, staging, and production environments. The containerized application runs identically on any machine with Docker installed, reducing deployment-related issues and improving software reliability. Fast and reliable deployment. Docker's lightweight nature enables rapid deployment. Containers can be started and stopped quickly, leading to faster development iterations and faster time to market. Additionally, since the container includes everything required to run the application, there are fewer chances of deployment failures due to missing dependencies or misconfigurations. Version control and rollback. Docker images are versioned, allowing developers and operations teams to track changes to the application and its environment over time. This version control makes it easy to roll back to a previous version of the application if the newer version encounters issues. Scalability and load balancing. Docker makes it easy to scale applications horizontally by running multiple containers across a cluster of servers. Containers are lightweight, so scaling up or down can be done quickly and efficiently. Load balancing can also be easily implemented to distribute incoming traffic among container instances. Isolation and security. Docker containers provide isolation between applications, ensuring that one application cannot interfere with another. This isolation enhances security and reduces the risk of security breaches. Moreover, Docker provides a secure, isolated environment for running applications, minimizing the attack surface. Simplified dependency management. Docker significantly simplifies dependency management. Developers can specify the exact dependencies required for their application in the Docker file. This ensures that the application runs consistently, regardless of the underlying host system's dependencies. Infrastructure portability. Docker enables applications to run on any platform or cloud environment that supports Docker, allowing easy migration between development, staging, and production environments. This portability also facilitates hybrid cloud or multi-cloud strategies. DevOps enablement. Docker plays a crucial role in DevOps practices by enabling a consistent deployment process from development to production. The same Docker image used during development is deployed in production, minimizing the "works on my machine" problem and promoting collaboration between development and operations teams. In summary, Docker simplifies application deployment by providing a standardized, consistent, and portable environment for running applications. It addresses challenges related to environment variability, dependency management, scalability, and security, making the deployment process more efficient, reliable, and developer-friendly. What is Docker Engine? The Docker Engine is the core component of the Docker platform responsible for running and managing containers. It is a client-server application that provides the functionality to create, start, stop, and manage Docker containers on a host system. The Docker engine consists of two main parts. Docker daemon, Dockered. The Docker daemon, or Dockered, is the background service that runs on the host system. It is responsible for managing Docker objects, such as containers, images, networks, and volumes. The Docker daemon listens to requests from the Docker CLI, command line interface, and REST API to perform various container-related operations. Docker CLI, Docker. The Docker CLI is the command line tool used to interact with the Docker daemon. Developers and system administrators use the Docker CLI to issue commands that build, manage, and deploy Docker containers. The CLI communicates with the Docker daemon either locally on the same host or remotely, depending on the configuration. When a user interacts with the Docker's CLI to perform tasks like pulling images, creating containers, or managing Docker resources, the CLI sends requests to the Docker daemon, which then executes the requested actions. The Docker daemon handles all the container-related operations, such as creating and managing containers, starting and stopping them, networking, storage, and image management. The Docker engine is the heart of the Docker platform, and its ability to create and manage containers efficiently is what makes Docker so popular and widely used in software development and deployment. It simplifies the process of containerization, providing a consistent and isolated environment for applications to run across various environments, from development to production, with ease and portability. If you enjoyed this video and found it helpful, please consider giving it a thumbs up, like, and sharing it with your friends. And if you haven't already, don't forget to subscribe to the channel and hit the notification bell to stay updated on future videos. Subscribing helps us reach more people and continue creating valuable content. Thanks for watching.